Sorry for the printer noise. I got something I need to print. I'm printing a 24mm SMD. See, some of these bigger packages, like USB, well, USB fits in these, but these are 24mm. These are buzzers and like ICs and stuff like that. You'll need the bigger ones. So I'm just printing some of the 24mm for that, so I can make a strip holder. I printed all these 8mm, what was it, 8mm, 14, 16, something like that. I don't know what size that is. I have one thing that's that size. Apparently there's a smaller size too. I didn't print that one though. I don't know what, I don't have anything that small yet. For now, all my components are just loose. I don't have any reels of anything really. I need to clean my stencil and get my coffee out of the way so I don't get lead in it. I don't want to be drinking lead. So, alright, put that to the side. Alright, I'm going to pull up my bomb and we'll go ahead and get stuff situated, selected. Zoom in here so I can see what I'm doing. I need to condense this bomb into a count. But for now, I'm just going to go through it real quick. Last time I used this little tray. Let's do that again. I'm going to go ahead and take these off of here. Let's see if that wipes off with alcohol actually. This is dry erase tape, but I don't have dry erase markers, so I just used a Sharpie. It should work just the same with alcohol. The problem is the Sharpie will leave. Oh, look, it's peeling the. That's the problem with this. It's probably going to peel this plastic off. Let's see what this is made out of. Huh. Looks like as soon as the alcohol hit it, it delaminated it. It's interesting. It's just some kind of plastic with a very high Teflon-y coating. I'm going to replace this with another strip so I can label these properly. I meant to design this big enough to be able to put a strip here and a strip here. So let me do that. I don't know if that's going to hold enough components. It should be big enough to hold all my stuff. Let's go ahead and get that tape and test it out. So here it is. It's a dry erase tape. It's really cool. It's really good for putting on anything. You know, you just throw a strip up on your tools and you can label each thing. And, it's pretty cool. I thought it was very interesting. I saw it on sale once. I got chalk tape too, blackboard tape. So I need to cut a piece of this off. I guess I will use a. Let me use a blade. PCB ruler, that should work. All right, so we're looking at 10 microfarad, 100 microfarad, 100 nanofarad, 1 microfarad. So we're going to do 100 nanofarad, 1 microfarad, 10 microfarad. I think that's good enough for now. And then we'll do our resistors. I need 10K and 470 ohm. And then I have one 4.7K R5. Let's see what R5 is. I don't really know what R5 is. Oh, my 3D printer's done. I should print out. My printer's messed up, or else I would print out a schematic. It's not printing right. All right, let's see where R5 is. Devices, R5. R5, okay, that's the pull down for GPIO 15. So I can just do that over here. Yeah, that'll work. Put the bomb on a different sheet so I can just go back and forth. 4.7K. And then I need some diodes. I have 3 diodes. They're supposed to be Shockeys. I only have 4148s in SOD 323. So I'll just have to use those. I have 3 of those. So we'll just do that over here. We'll just do DX. And then transistors, LEDs, and all that stuff. 500. I should change all these to the right value. They're not 500, they're 470. Oh, I don't remember this one having supports. Shoot. I meant to print this with, oh man. I meant to print this as a bridge. And I left supports on from the last print. Oh, this is going to be a problem. No, 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 no. Oh, you suck. It puts supports everywhere. Oh, even in there. I guess I should make sure it fits in there before I even bother cleaning this up. Well, it's already done. That wasn't too bad. I never printed with supports that small, and it cleaned up really, really easily. That was really easy to clean up. So this should fit in here. There we go. Just like, it's a little tight. had a feeling that was going to be tight, but that's good because I hate the one. These ones are all loose. I would rather it be tight. And you're supposed to peel that back, and they need to make it a little easier to slide this in. That's the only complaint I have. I guess you could put a piece of tape on there. Let's try that. Let's put a piece of tape on there. Get off, stupid. And then feed that up through there, like to make it a little bit stiffer. Pull it back. Yeah, so that works. Hey, look. I like that. Looks pretty good. Oops, I just flipped it upside down. So that seems to work. So the rest of these are a little too small. They just flop around. You really got to mount them down. So once I get this all situated, I'll have a whole set of components for each project, for this project, and I can deal with it properly and just label them. So let's just start with this and see what we're doing. These are, these should be 10K. How many 10Ks do I have? I need to count, I need to sort these by value. 1, 2, 3, 4, 5, 6. I don't think I have 6 in here. I only have 5. And the problem with this is if you accidentally let one flop over, it would be kind of cool to have a lip on these things so that they don't pop out and go into the other ones. That's 10K. I'll have to get my book out to get more 10K. This should be 47. So let me go ahead and plug my. This is my. I'm probably gonna redo this, but this I just threw this together one night real quick. And seems to work pretty good. So we'll toss that up here so it doesn't fall. I need to get this hose out of the way. It's kind of annoying. I kind of put this coupler on here so I could disconnect it and you know, experiment. But it's kind of not working out. I'm gonna have to rotate it to get the hose to hang properly. Whatever. Yeah, it's definitely not. The twist is wrong. Yeah, there's nothing I can do now. Looks like that's just the way it is. That's just the way it is. Got plenty of room here. I'm not zoomed in, so I can do this closer. See, I can get rid of all this stuff. I need all these over here. Oh, look, I just knocked them all off. Since you have to have a base for these. These should be 470 ohm. 2, 3, 4. 1, 2, 3, 4, 5, 6. I think I have a leak. Yeah, it feels like I have a leak. Maybe I didn't put that on right. So that's why I'm going to redo this. It's not even airtight. I just kind of shoved the tube through here. Nothing. It's not glued to the tip, so the tip's probably leaking air. There's a couple things wrong with it. Works pretty good though. Worked better last time. It seems to be having a problem today. I need to See if it's kinked or something. Alright, that's out of the way. This one needs to... That's why it needs to be tighter, because it kind of just flops around. Yeah, so where'd that tip go? Shoot, what did I do with my tip? Oh no. I need that tip. I can't do anything without that tip. Where did it go? Where did it go? And this needs to be on a base so that it's heavy, so it doesn't flop around. Shoot, what did I do with that tip? I can't pick up. Oh, that sucks. I think I have another one. I don't know where. I bet I let it fall down to the ground. This is the last one I have. I need to buy more of these. And there's a smaller one too. So now you can pick up bigger things. So that's how that works. 10 microfarad. What's that over there? What is that? That's a different kind of buzzer. 10 microfarad. Let's go ahead and set this up in the strip. The feeder. Oh no, it ripped. Oh shoot. Oh man, it didn't pull the tape off properly. Shoot, I can't get that tape off. That tape's on there really good. Sometimes I cut these with a hot knife and you can't get the tape off because it's glued on there. It's not glued, but it's, you know, melted on there. Why is that slipping? Why is this tweezer slipping? Jeez, I cannot get this tape off. That's crazy right there. I cannot get that tape off on that side. It must be the end of something that's... Hey, look, it's just ripping the tape. Wow, what the... You guys ever have tape that doesn't peel off? What was this, 10? Look, it's just ripping. It's not peeling. Huh. 10 microfarad, 2 of them. I only need 2 of these, so... That's messed up. Right there. That's really messed up. I don't know what's up with that one. Let's see what I have over here. I'm going to use this switch on this one. I made a footprint that does 2 different kinds of switches. There's a transistor. Oops, that doesn't go there, that goes there. I made let's see. I made a footprint that does 2 different switches. this one and this one. It's a side mount and a vertical mount. I think I'm going to do the side mount on this one. $100 nanofarad. I'm going to have to break out my books because I don't think I have anything out. So I need a 100 nanofarad. These 10 microfarad and these two. Yeah, I'm going to skip using tantalums on this board just to see if I even need them, because they are more expensive, and you know, a lot of people use clean power and you don't really need them. So I'm going to skip them. I'm going to just use I'll go ahead and load this 1 microfarad up, might as well. So you just throw it in there, push it through. You're going to feed your tape into the slot, and then just push it back and kind of grab it. All right, and then you're gonna, this one's real tight for some reason. And then there you go. Of course, you want to cut these ends off every now and then. So then we'll just, you know, if you get if you get the set up right, you won't have to have a tray for your parts. You'll just have all them read all the what were these again? These 1 microfarad. Shoot, I forgot. I didn't mark it down. Yeah, these are 1, right? Surely these are 1. 1 microfarad. How many? 1, 2. Let's take 3 out. I always like to have an extra so I don't have to dig again. I'll take 3, and then you can always tuck that back in. You know, so that's what I like about these. You know, pull the ribbon you pull your tape too much, and you can just tuck it back in. And it kind of secures it. Some of them are a little loose, but you could probably fix that. You know. All right. Now I need 100 microfarad. I'm sorry, 100 nanofarad. Where are my 100 nanofarads? What were these? What are these ones over here? Those are my 10 microfarads. Where'd that tape go that I had? It's that 10. I hope that's labeled right. 100. Actually, I really need to resort these. They should be in. They should be in order of. Of value. The 100 should be. Where are my 100s? I can't find my 100 nanofarad capacitors. Did I dump them out already into a 10? Oh, here's my diode. Here's my diodes. Go ahead and get those out. 1. Oops. Oh, come on. Oops. 2. 3. Shoot, I don't know where my 100 nanofarads are. This is a problem. Let me unplug this. Does that say, is it 100 nanofarad? That might say 100. I'm not sure. Yeah, I think this is it. It's in the wrong spot. These must be them. I will have to make sure though, because I can't read that writing. Shoot. Yep, that's them. 95. Close enough. So, see, I have another one, so I will just feed this one in here too. Actually, I should probably go this way. So then I could just go like that, and then roll it backwards, and then, yeah, that's much easier. I could just grab that. Yeah, so if your tape's real short, you could probably just add some kind of doubled over tape to it. And that should help pick them up. All right, so what am I doing here? 100 nanofarad. I usually put a smaller nozzle on, but since I'm doing just nothing special here, I'm just gonna grab like 4 of these. One, two, three, 4. Actually, I think I have more than that. I'm gonna grab 6. Cat's being crazy. Got the zoomies. See, I really like these. These work really good. Instead of having to dig in your books, if I'm doing a project, I just load them all up, and then if I'm doing more than one, I could just, mount them all up and use them. All right, so what else do I need? I need to get my LEDs and my ESP and regulators. I have 2 1 microfarad capacitors on this board. But I took 3 out. See, C8 is the reset. I could do either 100 or 1. Since I'm using both those values, I could probably use either or. I have 1 100 microfarad. And I think the only 100 microfarad I have is this 3216. Yeah, I'm pretty sure that's all I have. So maybe I'll get one of those out. I hate to skip. I'm going to skip that. I'm not going to put that on this board and see if I even need it. I don't think I even need it. But I am going to put... I'm going to take out at least 1 10 microfarad tantalum in case I need to stabilize the power supply. Well, it's like stuck in there. It wouldn't come out. I'm going to try to just use... I've seen some people use 22 microfarad on these regulators. I have to actually look at the noise I'm getting and see how to stabilize them, but a lot of times you don't even need to have, you just need the 2 input and output capacitors to stabilize the regulator. You don't really need the extra high frequency noise stuff. Maybe I got them from another package. Let's hope these are labeled. Everything's labeled properly. We'll look at everything up close later. I'm gonna take 2 out because I don't have to dig for it next board I make. And 4.7K. I would like to make this big enough so I can put the quantity right on here and generate these labels. Or have some other thing where you slip something in, you slip the labels in. You can just print them out and slip them in, and then you have the quantity so you know if something happens and you're missing something, you know it moved or jumped out or whatever. I think we're good. I think that's pretty much everything. I do need to get pick an LED. I think I'm gonna use. I'm gonna use one of these again. This worked out really well. Maybe I'll just put power LED on this one. I'm just going to take that out anyway, in case I decide to use it. I have some kind of LED in there I could always use too if I decide to. What else do I need? I need a transistor. I have a transistor. MBT222. I need more diodes. I need to order some diodes. Okay, so I have that. I have that. I thought my regulators were in here. Maybe they're not. Yeah, here they are. I need to put this inside. See, I think that's what this size is. See, I need more space. I need to put the. I need the compartment. I need to make this a little bit bigger. See, like these should probably be. I need to make more small bins. Yeah, that'll work. All right. So see how long that takes just to organize your components for one board. I probably forgot something. There's probably something missing here. Who knows? So, all right, so I got my components. And next thing I do is take my stencil out and apply the paste, get my heating plate, and then get my hot air warmed up, and then just assemble a board. And that's it. Should be good. Oh, there's one thing I'm missing. An ESP. I don't know what should I put on this board? I have I don't want to do this because that's going to be for a project. I have an ESP07. I'm going to save that for an actual project where I need an antenna. So I'm not going to use that one, but I have two ESP12s. I have the Espressif, and I just got one of these. It's a Do It. It looks really cheap. I really don't like the feel of it. The PCB material looks really crappy. The castellations look really crappy. But I'm wondering if I should test this just to see quality because these are probably cheaper. Yeah, let's try that one. We'll try that. I also want to try the AI Thinker ones too. I don't have any of those models. I got a bunch coming, but I want to try, make sure I source everything and try different versions of everything to make sure, you know, I'm happy with them. And I need to redo this. This was kind of made so I can hold a board like that. So there's the board ready to go. And then an ESP can go in there too, but the slot's not small enough for. I forgot that these are 1mm or whatever boards, PCBs. See, but whatever, it works. And I have to find that other one I just lost. I'm sure it's around here somewhere. So I would like to have a clipboard or some kind of material to put my stencils on. I think that would work out pretty good, but all I had was some manila envelopes. It's the heaviest cardstock I had around. So I just made it like a folder and just had some spare PCBs just stacked around there. Luckily this fits pretty good. Hopefully my stencil's still aligned pretty good. Just gonna check it for any clogs. Looks pretty good. That hole looks a little clogged. Just going to check these holes for any kind of leftover paste. This one on the bottom looks a little dirty. Yeah, there was a little. That's really why you got to clean your paste off, because otherwise you get some stuck in the holes. See, there's some in there. Just do this and try to make sure there's no hairs or nothing. All right, I think that's good. So the card I had. I like these little. I like the cards that are a little more flexible than good quality cards. So these reward cards or benefit cards are pretty good. The credit card sometimes a little too hard. Sometimes they're multi-layered and they're a little stiff. So this should work pretty good. Although the edges aren't the best. I'll use this one. It's the cut edge. And we'll grab a board. This is an idea I got from Harry on YouTube. I think it's Hayri. He uses aluminum heat sinks to organize his projects. So basically I have, if there's a problem, I can reference it real quick. I have some layers printed out. I have my traces and my pads and my silk screen. My paste. So if there's a problem, I can look at that real quick without having to pull up, the Eagle files or whatever. Oops, I can't get those in there. Did some of them rotate? Get in there. There we go. So I just have a bunch of boards available. I have like my, you know, but I have this smaller one for, you know, for just like the project I'm currently working on. So I can just, if I'm assembling multiples, I can just keep them in there, clean them off, stack them in there, and then pull them out as I'm pasting them. Ideally, you'd panelize this in a 4x4 or something like that, or 4x6, and you'd do the whole thing at once with a bigger squeegee. But that's all I got. So these boards are pretty clean. They just came out of the heat shrink, but I've been playing with them and checking them over. I don't know which ones I've grabbed and which ones I've not, so I'm just going to clean it off. Well, I'm not doing that side, but whatever. Clean it off with some alcohol. Make sure there's no oils on there from your dirty fingers. Or machining oil. They come pretty good. They come heat shrinked in a, not heat shrink, but vacuum sealed. So they don't, you know, they should, you know, they should last for a year before you try to manufacture them. You just leave them sitting in your bench until you're ready to do it. Let's see if that's too bright. I think that's good. This one goes this way. It'd be good to print out a picture of what, because trying to look at the stencil, it's hard to tell with the stencil. It'd be good to have a little reference mark. So maybe I'll put a dot here. This is a good idea. Watch this. I just came up with this. Watch this. My fiducials are there. And there. So that should help. It's also the same as my holes. So there's a fiducial there and a fiducial there. So, boop, in case I forget. And it fits real tight. I can tuck that in. Keeps it real tight. And everything's still, registration's still pretty good. All right, so I should be able to paste that without a problem. I found out you need to apply a lot more paste than you think you need. And if it's a dense area, you definitely want to have enough paste there. I don't know if that's going to be enough. We'll find out. Nope, wrong side. So we're just gonna, I don't usually like to do it more than once. See? That's not enough paste. So I really screwed up that time. So what am I gonna do now? Put more? That's gonna be messed up. It's not enough paste to go all the way to the bottom. Well, I'm gonna try to just do this once without lifting the stencil. You should never do it like this. This is the worst thing you could ever do. In fact, I probably just screwed this whole thing up. It's probably the worst thing you could do is do it multiple times, but I'm going to just leave it like that. I think I had it tight enough. The stencil was real tight. I think it's good. You can see I put a little too much paste on that center pad. I'm going to go ahead and zoom in. Yeah, so doing it multiple passes, you get a little too much paste. Some of it goes underneath it. But I think it's going to be okay. Yeah, see that big pad? Yeah, see, that's a problem. You can see that pad right there? The regulator? It's awfully close, and doing it multiple times put too much paste on there. So I'm going to just keep this board. I'm not going to redo it, and we'll just fix it if it has a problem. So you can see how much paste I got left on there. I'm just going to wipe this off. So you get your tweezers. I always have some. I have this. Whoop, stuck it right in the paste. Jesus Christ! Have somewhere to put your card when you're done pasting. Somewhere to set it so you don't get your arm in it. And I also have something to put the board in after I remove it. All right. I think it's okay. There's only one or two things that are really close, and I'm not going to worry about it. I'm not going to worry about it. It should fix itself up. All right, so then I'd probably need something to put under here to clean this paste up, but we're just going to do that. That's good enough to get it cleaned up. I got paste coming out the bottom too, but it's not too bad. So I got that one paper towel, and then I'll use another one. Now if I was going to do another board, I would just bang it out real quick. I wouldn't even clean up between each stencil. I would probably just go ahead and do another one. It probably would be fine. But this should be a lot easier to clean up and prep for next time, since I did that. It was totally worth cleaning up after I use it. And then I could just do that. A little bit of alcohol goes a long way. And then I'm just going to probably get a pocket to put this in. Put it in there. Put this away. All right, I need my balm again. I got my pasted board. I'm going to wash the solder off my hands. Turn that off so you can hear me. I should have had this pump turned off too. It's not too loud. Alright, so should I do this close up? Probably, huh? I think I'll leave this close up when I do this. Alright, so here we go. We got our components and our board. Maybe I'll do it fit better like that. Yeah, it fits a little better like that, so maybe I need to plan for that next time. This wasn't made for video, this was made for ease of use. My board is, I'm going to orient my board the way I designed it so it's more familiar in my brain. I am going to get here I'll show you what I'm going to do. I need to take these out so they're not hidden somewhere. I think that'll work. I'm not sure which one's better, that or that. These are, I bought a bunch of these. These are makeup brushes, eyeliner, makeup lip gloss. I think this is a lip something applicator, and this is a eyeliner pencil maybe. Not really sure. But I am not using an S module. So I'm just going to take this paste off the middle because I don't need it. Oh no. Oh shit. Well, don't pull them. They come right out. Whoops. So I'm going to take that paste off the middle pad because I don't want it under there, because there's no pad on this ESP. And I'm going to take a look at this right here and try to all right, let's do this. SMD components first, or the big components so you don't knock the little ones off. What's better? That's a hard decision to make. Probably little components so that when you move around, you're not working around the little things. Maybe I need a light. Yeah, I need more light. Is that too much light for the camera? Probably, but you know what? Sorry about you. I can't see. I'm gonna have this camera's like right in front of my head. I'm gonna have to raise it up a little bit. Just a little bit. Yeah, now I can lean forward without hitting it. Is my head in the camera? I don't think so. So I didn't make a turntable. I thought it would be a good idea, but I just printed this little round thing. It was a little easier, and it works pretty good. Oops. I've built one of these before, so I know where most of the stuff goes. So now I got this little area to drop stuff, to get it the right direction. On cam. Oh, I'm not even on camera. Shoot, sorry guys. So sorry. There we go. So sorry, so sorry, so sorry. That was a mistake. Sorry about that. But I was saying I got these little holes over here so I can pick something up and get it the right direction. I've seen people suggest like having a mirror, so maybe I'll get a little piece of mirror so I can see which direction the LEDs go. I think that's a really good idea, and or even a vibrator that you can tap. Some kind of little spring or something you could tap that flips your components for you, like rattles them until they flip over. I think that would be really cool. As far as making things go a little faster, especially if you're doing a bunch of boards. It gets to be a real pain in the neck. I think it also helped to have a magnifying glass. I have magnifying goggles, but I really need just a magnifying glass to hold it in front of, because diodes are real hard to find which direction they face. So let's do this transistor. How's that look? Is my head in the way? I hope my head's not in the way. It's hard to film without getting your head in the way. And this diode goes that way, so I believe the it's hard to see the line on the diodes. Oh, I want to get that out of there because it's confusing me. That does not. Yeah, I'm going to take this nozzle off because I don't really like this one in particular. have a is that green one, the little smaller one? I think the green one's the one I like for smaller components. Yeah, much better. So I gotta see which way this diode's going because I really cannot see it. And I don't know where my magnifying glass is. I have a magnifying glass. Alright, so let's see if I can see which... I still can't see which way that diode goes, man. I mean, why is it so unambiguous? How are you supposed to see that? How are you supposed to see which way the diode goes? Oh, is it upside? It's upside down. These packages are really hard to get the right way around because their legs stick out the bottom. And I still don't see which way that goes. Man, I'm having a hard time with this today. Is it a matter of getting the light the right direction or what? I cannot see this. There it is. It's getting the light in the right direction. Wow. So this is that way, which means it goes that way. Jeez, this is hard. It's not hard to see. Man, I cannot get the right angle on these diodes to see the stripe. There we go. The light's got to come in from the right direction. Great, now I get to do it again. Let's just do both of these at the same time. And I'm going to need some higher magnification, I believe. Maybe if I drop a light down at the side. If anybody's got any tips on how to do this, that would be awesome because I don't see anything. In the past I've used a ultraviolet. There we go. I've used a UV light to do it. Yeah, just get it the right direction and you can figure it out. You just gotta get the light to come in at the right angle with these things. They're so small. Alright, now once you know what you're looking for, you can get the angle right. Oops, I have the right way around. A little shaky today, sorry about that. See, what you're trying to look for is those little lines on the diode. I just need some better magnification, that's all, and side lighting. Alright, so let's see what goes where. I'm going to have to start looking at the bottom now because I'm not so sure about the rest of this. Alright, so C1, C2. C1 is 10 microfarad. That's C1 right there. C2 is right there. I'm going to guess neither of these capacitors are needed. C6 is 100 nanofarad. I don't think either of these are required. I'm sorry, that one's required. I don't think you need that one. 100 nanofarad. Where's the other ones go? 100 nanofarad. C6, C7? C6. C7? I'm not really... I probably don't really need these, but... these should be going on the... these probably go on all the... no, that's 1 microfarad. C7, C6, C3. C4 is 1 microfarad. C5 is 1 microfarad. That should be the neopixels. C4, C5. I don't think I need that one over there. I'm not going to put that on there. Pretty sure I do not need one. I didn't put one of those on the other board, but I'm going to put one here just to stabilize the 3v3 on that side of the board. See if it helps some problems I was having. These are IT squared C pull-ups. I don't need those. I probably shouldn't clean them up. This is auto reset. I have to bodge that. That's a SHT. I wonder if I should put an SHT on this board. I think I'm not gonna. I think I'm gonna put it on another board and use it as a breakout and to test it out. I think that's it for the capacitors. Let's go to resistors. We got R1, R2. All right, so we have these 470 ohms. They're going R1, R2. Here's R1. R2 and R, is that R8? R2. I think this is R8 right here. And that one right there is R13. So I could probably use a 4-way for all these resistors. And then what's that? Oh, is that R9? R9, what is R9? This is another 470. There's a lot of 470s over here. These are all the inline resistors for... This is the inline resistor for the neopixels, inline resistor for the LED, inline resistor for the transistor, inline resistor for the pull-up for the transistor, since this is a piezo. That is the resistor for the volume limit that's jumped out usually, but if you want to drop the volume down on the piezo, you can change that value to whatever you want, and then change a jumper on the back. I'll go over all that separately. What else? Regulator. I'm going to skip that capacitor right there and see what happens. That's what I'm going to do. I have to remember how this goes. I'm pretty sure this LED goes... I'm pretty sure this goes... I'll put that there for now. Line on this side. I'll have to double check. I always forget. There's a 4.7K. That's R6. Did I screw that up? That's R6's. That's the... I could probably change that so I don't have that one strange value. That's the... oh, it doesn't sound right. That's the limiting resistor for the reset button. I don't know that you actually need that. I'll have to try to eliminate that part. Those two resistors I'll probably try to eliminate because I probably don't need them. I could probably use a different value, maybe just a 1K, or change some other value so that they match. What else we got here? That button. Go ahead and put our button on. The button was hard because it has some pads. It has holes that it mounts to. Alright, so this LED needs to go on. I'm pretty sure the polarity mark goes... Polarity mark is up. Polarity mark goes this way because the polarity mark indicates ground. And that is ground right there. Well, that doesn't look like it has enough paste on it. Yeah, it should be right. Oh, damn it. All right. I think that is right. Seems right. All right, because there is a dot. I do have a dot there. That's usually where the polarity mark goes. What else we need on here? That diode's a little crooked. Maybe I should try to fix that. You really don't have to fix anything. It'll flow correctly, but I'm just worried about that one. And I'm gonna put this. All right, so now I need to switch out to a larger. I'm gonna go back to this because I need a larger thing to put this down. And I need to do the NeoPixels. I'm gonna leave that one off because I can do that one hand-soldered really easily. I want to see if it's even required, and I need to get some I've seen. I don't think Adafruit puts those on their boards. Maybe they use a better regulator, and you don't need it. I don't know, but I guess we'll see. I gotta put the USB on there. I probably need to use tweezers for those. Those are hard to pick up. Actually, let me put the, yeah. Those are a little harder to pick up with this. Oh, that should work. Those are hard to get in because you gotta get the pins aligned, but once you do a good job, and you want to straighten your USB connector or make your footprint tight enough so that well, that glare is a little bright. Sorry about that. I couldn't see the you want your USB to be straight unless your footprint's tight enough that your legs fit in perfectly, but then it's going to be hard to get in there. So just tap it into place. It probably is going to move anyway, but you know. All right. Positive goes here. I'm going to spin that around. We're going to put the ESP on there. Just like that. I might tap it into place a little bit better so it doesn't move around. I don't want it to float too much. Could knock stuff off. And now I'm going to put the NeoPixels on. I don't have those out because they can go bad. I really should have baked these because they were not hermetically sealed. What size do these go in? I guess I need more of these. I need to print more of those. Those goes in. This go in the one with the regulator. So I got to print one more of these size. Yeah, I don't know what size that is. Oh shoot! Oh jeez, get in there. All right, so like I said, this really needs to be strapped down to prevent these problems. In fact, I'm going to take this off because you can't see what you're doing. And these go notch. Notch goes over here. In fact, I'm just going to take the rest of these out. Alright. So then I can just pick them up the way I want them. The good thing about having ribbons is that you know which orientation your items are. They should be in the packaging in a predictable orientation. But a lot of times SMD pickup machines do need a machine vision so they can just double check, because sometimes they're not. I'm going to fix that, make sure it's away from that pad right there. I think that's everything on the board that we're going to put. Yep, time to reflow. So we'll get that out of the way. All right. So we're going to reflow now. Turn my hot air on. I went over a lot of this on my stream, but the quality wasn't so good, so I'll do it again. I can go ahead and turn my suction off. I am going to, let's just clean that off. That's I think that's some flux that's on there. Just don't want it on there, so it doesn't stick to the board. This is a just like a heating. I think this is a candle warmer. Not warmer. It melts the candle melter, whatever. It melts candles so you don't have to burn them to get the smell. Kind of like a coffee warmer, but this gets up to about 200 degrees Fahrenheit. So I found out it was really good for getting my boards up to pre-temp so that I don't have to reflow them so much. Now with a small board it doesn't really matter, but this board's got, you know, a little bit of mass to it. And I want it to reach some kind of equilibrium. You know, I want the board to be at the same temperature so it reflows faster. If you're just trying to hot air the whole thing, you're going to have a huge variance of temperature across the whole thing. And for a board this is 40 millimeters by 40 millimeters, it's not humongous, but it's big enough to cause a problem with hot air, I think. A lot of ground plane, and it's using an ESP module, and you can really kill your neopixels if you don't flow them quickly. And then this piezo's, I'm a little sensitive about the piezo too, because it's not the best, and these little buttons can melt as well. I mean, not typically, but if you hit them too high, they will melt. So we'll just put the side light so you can see. And we'll have to refocus on this because it's up higher now. And is that too bright? Might be too bright. So I'm going to turn my hot air on. It's about, I think it's set to 350. This plate is at, well, let's turn it on Fahrenheit because I don't really know C. It's 161 right now. So this is going to kind of do the ramp up, the preheat of the board that you would do in a reflow oven. And this is just going to make it so that I don't have to hot air so much, and I don't have to work on a small area and then keep moving around. And the problem with that is you get components that are half flowed on one side and they don't spin in the right direction. They don't organize themselves properly. So as soon as this hits 200, we'll give it a little bit longer for the board to warm up, and then I will start working on the reflow. Now I'm going to try to not knock my camera off here because this cord is, my phone's on low battery, so I got to see where I can leave this. I'm going to leave it right there. That should be good for everybody. I'm just going to start working on it. Now, since this area is densely populated over here, I'm going to work on that first. I'm also going to get the corners so the neopixels warm up slowly. And this should help the neopixels not pop if there's humidity in them, because the temperature is coming up a little slower than I've blown some other ones out before. So we're just going to check on the temperature now. 220. I'm just going to start covering the whole board. Hope that air's not too high. I don't want to blow anything around. Hope you can see. Yeah, I think you guys can see. And you're going to watch for the solder to start glistening. You want some light on there so you can see when it's starting to go. You want to keep your reflow under, 3 minutes. So you're going to really start to get aggressive now. It's been too long. Make sure I didn't turn that down. So I'm going to get in there now and start glistening, and now it's going to start reflowing. I'm just going to start hitting everything. Make sure your neopixels reflow. See it pull? I'm going to hit this one. Let that reflow. Let the switch reflow. Hit this regulator. This piezo is going to take a while. I want to get them all at once. I'm going to do all these resistors. I'll start doing the ESP. I want it molten so it Straightens out pretty properly, and then I'm going to hit this last neopixel, these last two, let them go into place. Do them from the outside because that's going to heat up first. I'm going to go on the inside. That one might need a, nope, didn't need any help. Then I'm going to hit this USB real hard. And I think we're done. And if I didn't get something, I could always hit it later. Touch it up with a soldering iron. But I think we're good. I think I did a really good job at that. I think it's all reflowed. Turn this off. And I want this to cool down quickly. Whoops, because I probably left it on there too long. I forgot to turn this off. I should have turned this off a little earlier. I'm going to check the neopixels for, whoops, check the neopixels for bubbles. If there's no bubbles, they probably are okay. All right, I'll wait for this to cool down so I can get it out of the way. And I want to go in here with the loop and really check it out. Let's see what the temperature is. 100 degrees Fahrenheit, not too bad. It's already coming down. Come down pretty quick. That aluminum really sucks the heat out, and that's what you want. You want to cool it down as fast as possible. Not as fast as possible. You want it to have a nice little curve. So leaving it on the hot plate a second wasn't really doing any much damage, but it's a little too hot. Normally I would have a controller to bring that up and then bring it down. So it's already at 80-something degrees. It's already almost at room temperature. So I can handle it now. And I don't know how long that took, but it was, whoops. I don't know how long that took, but it wasn't too long. Probably under, I wouldn't say it was 3 minutes, but maybe about 4. It feels like it's moving. Might have to touch that up. All right, so you probably won't be able to see this, but I'm going to get in here with the loop just to look at everything. Which means I need a lot of light. The higher your magnification is, the more light you need. In fact, I don't even have enough light, and it needs to come in at an angle. Check that diode, looks good. I'm gonna check all the neopixels. Looks good. Looks good. Looks good. Not exactly straight, but whatever. Check the ESP for any shorts. Nope. Check this neopixel. Looks good. Check the other side of the ESP for shorts. That looks good. All the resistors look good. Capacitors look good. Regulator is good. Ground pad is good. I'm going to check on this USB. USB is flowed through to the other side. USB is good. Check the pins on the USB. USB is also good. Piezo looks good. The only 2 pins that I count on the piezo are these 2. These are just to hold it in. I'm going to check on that switch because I think there's something wrong with the switch. This pad wasn't really made for the switch, I think. I didn't really adjust the pad size enough to do that. Yeah, it looks like it might need some work. I might just touch that with the iron. But let me check all these stuff over here. Make sure there's no short in the SHT sensor. Make sure these this diode flowed. Make sure these resistors flowed. I'm going to check on this little tiny neopixel. It looks okay. Looks okay. Check the transistor. Resistor looks okay. Diode looks okay. Everything's in the right direction. This last neopixel. Not so shiny as I would like it to be. It's probably okay for now. I'll hit it later with the iron. It's good enough. This is what I was using to hold the boards, but I just had to dump the boards out because I need a heat sink. I need to get another heat sink just for that, cooling boards down. Probably a smaller one. I don't need one so big. All right, so what we are going to do now before we even do anything, unplug this, get rid of this. Don't need that anymore. Pull out, get that light out of your way, and I'm going to do some tests. Now I know that this is a problem here. Let me find something to put under there. Okay, we'll just do that. That should, yeah. Just got to angle the LCD so it fits right. Now I have my probes hanging on a thing. Hopefully it doesn't hit my camera. All right, so we're going to do some quick tests. Ground to positive. 22K. Sounds good. Ground to ground. Ground to 3v3. That sounds about right. 3v3 output to 3v3 input. Yeah, I think there's a real low, I think that's normal. I don't know why that's normal, but there's a reason that works like that. We'll check the buttons for short to ground, because the ground is just for the shield. 1K, that's okay. Open. Yeah, I think that one over there is not connected. I think that's why it's clicking when I push it. Everything looks okay so far. Check the ESP, ground to positive. 1.3K. I don't know why that's so high. I mean low. It shouldn't be. I would think it would be higher than that. I don't know, but let's power it up and find out. So I'm going to use a power supply. With I guess I could leave that. I'll leave that out in case I need it. In case I need to test voltages on the regulator. So I don't have an adapter for USB. I need to get one. But I'm just going to test it with the inputs. So we got 5 volts. I'm going to current limit it at about, I don't know, 200 milliamps. It's really too low to blow anything out. This time I'm going to check the polarity on my that's the wrong probes. Why did I take those out? That's the wrong thing. Check the polarity on my power supply and make sure it's the right polarity, first off. And then I'm going to take these and just plug some micro clips into it. And we're going to go to VCC. and ground. Oops. I need to clean these. They're like, well, they don't lay flat. I wish the probes came out the other side so that it would lay flat. I don't know why they do them like that. There you go. You should be able to see that. Let's do it. Okay. The ESP is going into a reset loop and it's maxing out current limit. Let's do it to 300. And it booted and dropped down to 73 milliamps, and it's fluctuating from 73 to 100. That sounds like normal behavior for an ESP. I reset it. Okay, reset's not working. I think there's something wrong with that button. Definitely something wrong with that button. Let's turn this off again. Back on. Off again. Back on. I don't know why I'm getting a double flicker there. It doesn't sound right. Let me check the voltage on this regulator. This is going to be ground and 3v3, 3.2. Oh, it's backwards. Well, that hell. Let's check it across the 3.3. No massive voltage drop anywhere. I think it's good. I think it's good. I think it's good. So now we're going to hook it up and see if we can program it, I guess. I wish that NeoPixel was straight, that one over there. I'm going to have to touch that button up and see what's going on there. Let's do that. Let's pin out that button. Is that on camera? Yeah, it's a little too shiny. Put it over here. On camera? Yes. Wires are in the way. Sorry. Let's try to figure out what's wrong with this button. Tell me this is a momentary. Well, that's weird. That's really weird. Why is that? Tell me this shorts front to back, not side to side. I guess I should have tested these switches before I started using them. Well, if it was shorted, then it wouldn't boot up, right? I'm really confused here. My battery died on my phone. I'm going to get some of this stuff out of the way. I think I know what the problem is. I took a closer look. Let me just get this stuff out of the way. It's just too much stuff for what I'm going to have to do. So actually, let me see. I think I know what the problem is. And if you're watching this video, you might already know what the problem is. 5 ohms. This is supposed to be 470 ohms. I grabbed the wrong resistors. I made 2 mistakes. I grabbed the wrong resistors out of the book. I wasn't paying attention. I grabbed 4.7 ohm. And I read the wrong row and put it on. This is the reason you only pull out one item for what you need. This is a good example to not. I pulled out two of them. Remember, I pulled out 2 of the resistors, so I don't have to go back in the book and get them. I wouldn't have made this mistake if I only pulled out 1. I would have made 1 mistake instead of 2 mistakes. I read the wrong row for this resistor and put a 4.47K, which is really a 4.7. And I wound up putting the wrong resistor on 2 locations. So now I got the right resistors here, 4.7K. I'm gonna double check it. Next time I'm gonna double check everything. 4.7K. That's right. So now I gotta reflow these 2 resistors. I don't think I'm gonna reflow them because I'm gonna melt that. I think I am going to rework it. So they're both on this side of the board. I'm going to put this over here, clamp it down. I mean, it might need to be a little bit tighter. Yeah, okay. Actually, should I change size? Nah, whatever. I'll just use a giant wedge. I have a real small tip, but I am going to get this out of the way. I have a small SMD tip, but I think I'm just going to use my wedge and just remove these manually and just rework them manually with the big tip. Gotta be careful though, because my camera is plugged up now because the battery died. It might die again. I'll try to do this pretty quickly. So the secret to removing SMD components is, let's do the easy one first so I have practice, is Flux. The reason you use Flux for removing is because it conducts heat better than the air does. So it's hard to heat, unless you have a pair of SMD tweezers, it's almost impossible to remove a resistor without completely destroying it or the board. If you use a little bit of flux, it'll let you conduct heat across the resistor or across the component and remove the whole thing at once. So that's what we're going to try to do here. So basically we're just going to go at one side, at the other side, and then I'm going to try to conduct the heat through and just remove it on one sweep. See? And I'm going to clean up the pads. I'm just going to take off some solder. Alright, so I was able to remove this resistor without frying it or the board. And that could have been a lot more aggressive. I could have just put it on the side, heat both of them at the same time, and just pop it off. But usually it sticks to the iron and it flies all over the place and it's just a big mess. So I'm just going to put that over there for now. You can actually reuse that resistor if you had to. It's not burnt up. I got my iron on 700. I think it's pretty close to the actual temperature. I'm not really sure. I haven't checked it in a while. This one's going to be a little harder because I'm going to try not to melt the. I'm going to try not to melt this thing. Usually you can go at these from one side and just let the heat flow through the other side. There you go. I don't know where it went. I lost that one. That one probably flew off my iron somewhere. So that was really easy. I just got to make sure it didn't go on the board and short something out. And that one came off pretty clean. I don't really need to redo that one. So I am going to. I've never used these tweezers before. They seem like a more natural. When you're doing it on the table, they seem to be a more natural curve because you're not holding your arm at a weird angle. I don't know if they're going to help this at all. And they're sticky. Gotta clean them. So I mean, It might help me solder that. What if I just hold it like that? I'm just going to hit that one side. Let it go. Then sometimes if you hit it too long on the other side, it will move. So I'm going to put some solder on my iron. Oh, this is lead free. Whoops. Oh, I should have picked the other one. I did the wrong solder. And I'm just going to hit that. And that should be enough to reflow it underneath it. And some flux would help there. That should be good enough to fix that. I mean, it's a little off the pad, but whatever. I'm not going to redo it. I'll just mess it up enough to do it twice. And then we're going to do this one. We're just going to put that there. And let it go. I didn't even put more solder on here. I'm just using the solder that was already on there. You could put flux and wick it off and start from scratch so the components lay flat properly. I really don't care. Which side did I do again? Did I just do the one side? I'm gonna hold this in case I take it off. That should be good. That was pretty easy. I mean, I could go a lot quicker if I wasn't showing you. I'm just going to check this. Make sure it's soldered. I need to get a lit loop. Yep, that's on there. That one's a little not straight, but it works. In fact, I'm going to leave this in this now because it's probably going to short something out. These jigs aren't the best for... sometimes I'll put it in here to power it so it keeps my test jig straight. I'll leave my iron plugged up in case something needs to be fixed. Oh, did I put the wrong one on there? Shoot, did I? I did put the wrong one on there. I did it again. I did it twice. I put the wrong one. Oh, I can't believe I just did that. I just replaced both of them with the wrong resistor. Only R5 is 4.7K. Ah, well. See, this is why you pay attention when you're doing stuff. I'm trying to be... Again, I took two out and replaced both of them with the wrong one. This is R6. R6 is a 470 ohm, not a 47K. Jesus. 470 ohm. Let's try this again. My Lord, I'm just messing this up. Oops. Anyway. If you want to clean that up, you take your alcohol and you get a little thing and you go in there like that. Maybe get a brush. Maybe just a little brush and just kind of clean it up. some non-lint, some lint-free. These aren't very lint-free. They're lint-free for a second, but not for very long. But yeah, if you clean up, it'll be nice. And sometimes you don't want that extra mega ohm of resistance in there when you have flux. That much flux will cause some problems. Alright, let's try this again. If I want to leave this, I might leave this in here. You know what? Is that really going to touch any pads? I don't think that's really touching anything. It might be. Let's do this. I think we can do that. I think we'll be okay. I think we'll be okay there. And then we'll put this over here. This just makes it easier so that your clips don't fall off. I mean, I need to get another one of these and just use it as a test jig and put some insulation on these things. I would expect that to I don't know, I would expect a reset to trigger that's a reset. See? That's a reset. This is not resetting. Oh, I'm so stupid. I'm such an idiot. This switch shorts pin to pin. The other switch, these switches short pin to ground. They switch back and forth. This one switched this way to this way. I didn't even pay any attention to how that works when I designed this. I didn't even think that this switch is pole to pole instead of side to side. I need to rework the way this works. Actually, I just can't use this button. It's impossible to make the two work together because one, unless I put an offset in a separate pad, there's no way for this button to work. Ever. Because these two pins are connected straight together. Alright, that might explain what the hell my problem was. I am so stupid sometimes. And that's how you discover design problems. By just building it and realizing how many stupid mistakes you made. Alright, let's try this again. I've mangled my leads. Alright. It works now. Let's see if we can program it. Stupid, stupid, stupid. I have a programming jig that I used for the 3 things you need to program it. And I need to make a jig that, I don't want to solder headers on this yet. So I need to make a jig that just works. Alright, I need to boot into boot mode with GPIO 0. To ground. That's VCC. That should be boot mode. Let's see if it works. Come on. Come on, please, Kyle. And it's programming. This is the janky. Oh. There it goes. It works. Let's try one more thing. I need to change this to pin 0. Whoops, no, not that one. Just pulled up in front of my house. All right, there you go. It's working. All right, so gotta take that out of there. All right. So it works. I gotta get that working. I have to change a jumper to get the LED to work. There's a jumper on the back that this one I bodged. There's a jumper here that connects the power LED to ground or GPIO 0, or you can use a RGB LED and send data to it instead. Problem with that is when you have it set up for auto programming, every time you write to GPIO 0, it resets the board because it's hooked up to some components that auto reset it. There's really not really a way to get around that, other than to use the Node MCU 2-transistor method. But I'm using DTR method. So for programming, this is going to be my development board. For programming it, and I have some circuitry I need to fix right there. I just cut that trace, and then instead of jumpering it to GPIO 0, I bodged it over to GPIO 14. Of course, it's the only one I didn't have breakouts for, test pads for. I jumpered it over to GPIO 14 just because it's an unused GPIO. And then that lets me test out that LED.